Laser World of Photonics, I am here at the booth of LIGENTEC, the key supplier of silicon nitride photonic integrated circuits. Heterogeneous integration is now a big part of the roadmap technology portfolio. Michael Geiselmann, what's new at LIGENTEC?
Yeah, thanks for coming by. We have a really busy show here, and yes, you're right. We are known as the PIC provider for very low loss integrated photonics, which is based on silicon nitride. And I think why you're here is the heterogeneous integration. So we integrate photodetectors, but also now modulators, which is very hot, and this is why you're here. So we are now offering multi-project wafer run and dedicated runs to integrate lithium niobate on low-loss silicon nitride.
In the last years, Thin Film Lithium Niobate has gotten a lot of interest from the photonic integrated circuit industry. You have proven already with 2 MPW runs that you can do this on silicon nitride. What is the reaction from your customers?
Yeah, that's correct. So we co-integrate with the base of silicon nitride. We put the lithium niobate on the top, and the reaction is very good. We get very low coupling losses, we get very low propagation losses, and we can, in a standard MPW, we can go up to 20 gigahertz, and in dedicated runs, we have shown in a research collaboration that we can go up to 110 gigahertz of modulation speed.
You can do 110 gigahertz modulation speed? Is that part of a PDK already?
That's correct. So we are working on getting that in the PDK, but customers can, as of today, order dedicated runs to get the 110 gigahertz modulation speed.
So in short, how does it compare to use TFLN on silicon nitride or to use a standard TFLN platform?
We are targeting customers that are really worried about losses. It's all about losses, and integrating modulation technology on a very low loss platform. That is where our customers come to us. The big advantage also is that we can use all our standard components in silicon nitrides that we have developed over the last 10 years. So you don't have to reinvent the wheel and do a splitter and redesign a splitter in a new material. We can use the old material, the low loss nitride material, to have all the PDK components, and you just add the modulator to it. So customers that have taped out with us over the last years can use their components and now add the modulator technology.
As a pure play foundry, of course, you don't really mind too much about the application. It's your customer that comes with the application, but can you reveal a few of the key applications that your first customers are targeting?
Yes, so our customer comes with the application, but obviously we are in contact with the customer to develop it towards the right direction. And we have customers in quantum, we have customers in space communication or space technology to get the modulators on the nitride. And we also have customers in telecom that are looking into integrating the low loss with thin film lithium niobate.
The biggest doubt that TFLN platforms are having is scaling up. Is the semiconductor market gonna adopt this? You are bringing still your collaboration with semiconductor fabs to take this to upscaling.
So the big advantage on the technology approach that we are doing is that the front end of line is fully semicon compatible. We fabricate in an automotive 200 millimeter CMOS fab. The silicon nitride is fully front end. Only the backend process is lithium niobate. So you don't need the full CMOS fab to let lithium niobate potentially contaminate the CMOS fab. We can take the lithium niobate in our process just in the back end of the process, which makes a tool investment much cheaper.
So right now we have a platform that's very suitable for the in-coupling of light, for the easy to put fibers in front of silicon nitride, great modulators, and also fantastic detectors.
Exactly. So the other integration approach that we do with detection is using microtransfer printing to put tiny 3.5 detectors on our low loss nitride platform, and we can get there up to speeds up to 50 gigahertz, and we can choose in the end the donor wafer. If someone wants to have a higher speed, we get another donor wafer, and the microtransfer printing process is the same to integrate and also higher speeds for the detectors on our low loss platform.
Michael, congratulations on everything that you are achieving. It's incredible how you can already have TFLN platforms on silicon nitride.